Hello everyone, today we will discuss Cannizzaro reaction for class +2. It is quite important. After aldol condensation, it is second most important reaction for class +2 and as well as for competitive exams. So what type of compounds undergo Cannizzaro reaction? First, it is only shown by aldehydes. It is shown only by aldehydes. Ketones never show Cannizzaro reaction. So it is a difference between aldol reaction and Cannizzaro reaction. Ketones undergo aldol condensation also, but ketones never show Cannizzaro reactions. But all types of aldehydes never show Cannizzaro reactions. Only aldehydes which do not have alpha hydrogen. The aldehydes which do not possess any alpha hydrogen, those aldehydes show Cannizzaro reactions. So we can say examples are formaldehyde and benzaldehyde, HCHO and C6H5CHO. They do not have any alpha hydrogen, so they will undergo Cannizzaro reaction. And the condition required for Cannizzaro reaction is we require strong base, and that is concentrated KOH or concentrated NaOH. So condition is also different from aldol condensation. In aldol we have used diluted NaOH or diluted KOH, but here we require concentrated base, concentrated KOH or concentrated sodium hydroxide. Actually it is highly basic. So for this reaction we require strong base. In aldol we have used diluted alkalis, diluted NaOH or diluted KOH, but here we require concentrated base, concentrated alkali. Second, it is the reaction of aldehydes which do not have any alpha hydrogen. So at least we require 2 units, 2 molecules. So its chemical reaction is one molecule of formaldehyde plus second molecule of formaldehyde. So we require at least 2 units, and the condition is concentrated KOH. Actually this reaction involves auto-redox reaction, means oxidation of one molecule and reduction of a second molecule. As we know, aldehydes are oxidized to acid and aldehydes are reduced to alcohol. So one molecule is oxidized and second molecule is reduced. So this is reduction and this is oxidation. Actually in oxidation reaction we form potassium salt. This is potassium formate, or we can say salt of potassium, potassium formic acid or potassium formate. So Cannizzaro reaction is simply auto-redox reaction. Or we can say disproportionation reaction. Auto-redox reaction means oxidation of one molecule and reduction of another molecule, but molecules must be same. That's why it is called auto-redox reaction. So Cannizzaro reactions involve the reduction and oxidation, or simultaneously oxidation and reduction of aldehydes which do not have alpha hydrogen. The aldehydes which possess alpha hydrogen, they undergo aldol condensation. So what is the mechanism of this reaction? Let us understand it with the mechanism. So mechanism of this reaction is For example, we have formaldehyde again. This is formaldehyde HCHO. So the reaction starts in basic medium, and we have concentrated KOH. So this will give OH ion. Now we do not have any acidic hydrogen in a formaldehyde, so it will not abstract any hydrogen, so it will act as a nucleophile. So here we have a hydroxide ion act as a nucleophile. So nucleophile will look for a positive center, and here we have positive center. Oxygen is more electronegative, having partial negative charge, so there is a partial positive charge on a carbon. So this nucleophile will attack on a positive center. So what we will obtain? We will obtain HOH H. So these pi electron will shift to oxygen, so oxygen will show negative charge, right? This is formed ion formed is called a hydroxy alkoxide, and here we have carbon 1, so sodium methoxide, hydroxy methoxide. So in step number 1 we can give it as step number 1 attack of a nucleophile. So mechanism involves step number 1, that is attack of a nucleophile. Nucleophile comes from base concentrated KOH, and the product formed is intermediate formed is hydroxy methoxide. In general, simply we can say hydroxy alkoxide is formed in step number 1. Step number 2 actually, and this is a first step. Step number 2 now second unit of formaldehyde. HC H double bond. This is our second unit of formaldehyde. In step number 2, if we shift this oxygen to this carbon, then there will be unstable product formed. So what will happen in step number 2? There is a formation of a hydride ion, and hydride ion shifts. So step number 2 is hydride shifting. Hydride is H negative. Now how H negative will form? This negative charge comes to this bond becomes double, so these two electrons are given to hydrogen, and hydrogen is removed as a H negative ion, and this H negative attack on a positive ion. So now we will obtain this structure. This bond is broken down, this becomes double, and now we have second molecule. This H is attack on a carbcation, and these pi electrons are shifted to oxygen. So in step number 2 there is a shifting of a hydride ion. This hydrogen comes from this bond, these two electrons are given to hydrogen, and now H shows a minus charge. This shift to positive center. This is step number 2, shifting of a hydride shifting. Step number 3, proton shifting. Now we have two molecules. I am combining it CH3 O negative. This is formic acid formed. Acid gives hydrogen, so this proton H positive is shift to this, so we will obtain, and initially we have potassium ion also present in a KOH. So this potassium will attack on this oxygen and this hydrogen is shifted to this oxygen, so this will become alcohol. So now finally we have HCO, okay, plus CH3OH. This is potassium format, and this is a methanol. So by this mechanism, two aldehyde molecules which do not have alpha hydrogen, one undergo oxidation and one undergo reduction. Actually acid is never formed, potassium salt is formed. So this is potassium format and this is methanol. This is the detailed explanation of Cannizzaro reaction. Again quite important for class +2 exams as well as for a competitive exam. It is slightly different from aldol condensation. The main difference is condition. Here we used concentrated KOH, but in aldol condensation we have used diluted NaOH. I hope you would understand it. Thanks for watching.